Okay, today we're going to go over the last little bit of chapter 9, the trigonometry bit. And there's a lot which could be said about trigonometry. We are going to keep it to the very basics. And the most basic part is, of course, SOHCAHTOA, which reminds us that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And that is the only bit of trigonometry we're going to use, right triangle trig. So it only works right now for a right triangle. So if I were to label the three sides A, B, and C and pick a specific angle and say, okay, this one we'll label with the Greek letter theta. The sine of theta is the ratio of the length of the leg opposite the angle to the hypotenuse. So A over C. Cosine of theta is the adjacent over hypotenuse, so it should be B over C. And tangent of theta is that opposite over adjacent, so A over B. We did go through the relationship. This is the Greek letter phi up there. Then the sine of phi is going to be B over C. The cosine of phi is going to be A over C. We get this kind of crisscross thing here. And this one gets churned upside down, much like you have to churn applesauce to make it. So I always say crisscross applesauce is kind of that pattern there. So we can use this in conjunction with things that we already know, like for example, if I had a right triangle, which had a 30-degree angle in it, then the sine of 30 would be the ratio of this side to that side. And even though I don't know what those two sides might be, I know what their ratio is. In a generic 30, 60, 90 triangle, we call this x, and we call that 2x. So we could say it's 1x over 2x, but regardless of what the x's are, it cancels out. And if we wanted confirmation of that, we could just type in sine of 30 degrees into our calculator and get that 0.5, that 1/2. Remembering that this is x square root of 3, we could find the other two trigonometric ratios for 30 and all three of them for the 60 degrees as well. Additionally, we could do 45. What we can't do is 90 degrees because remember what sine really means. It says in a right triangle, which also has an angle of whatever we happen to mention, theta, 30 degrees, 60 degrees. And you can't have a right triangle which also has another angle of 90 degrees. At least not this year. We'll see how that shakes out in later years, of course. That was about half of the battle. We had, obviously, no need to memorize it, but we had this chart here in the book. And I understand that it's probably way too small to actually read on the video, but what it did was it listed angles, listed the sine, the cosine, and the tangent of those angles. What's brilliant about this chart is that it works both directions. So if I know the angle in question, I can find the sine, cosine, or tangent. But if I know the ratio of sides, I can find the angle. So it allows us to do problems like where we look at one of our favorite triangles, the 3, 4, 5. We really don't know what these angles are. We're at that stage in the year where so many things are 30, 60, 90 triangles that people always try to wedge a 30-degree angle in there, but it's just not true, because if it were, this side and this side would have to be in a ratio of 1 to 2, and they are not. So I'm going to call this theta for a moment, and I'm going to notice that the sine of theta is 3/5. Our chart does things not as fractions, but as decimals. So 0.6. The cosine of theta equals 4/5 or 0.8, and the tangent of theta equals 3/4 or 0.75. And what we could do is we could look through our chart before, see if we can find a sine of 0.6. And let's see if I can zoom in enough that we can kind of see what's going on here. So if you notice, it doesn't come out to be exactly 37 degrees or exactly 36 degrees, somewhere in between, maybe like 36.8-ish or something, who knows? But the book can tell us that somewhere in here, that's where we're going to find that angle. So it's about 36, 37 degrees. That is pretty much all we did with trigonometry. Of course, we would solve some problems. And so let me do one or two of those. So they could give you a triangle like this. They could say, hey, you know what? I'm able to measure this side. This is the height from the ground to the attic of my house, and that is 25. We're able to measure this side, and this is the distance from my house to the wall in my garden, and it was 100. And maybe I want to find this angle, which we labeled with a theta. Well, I can say that I know this one and this one, so the trigonometric ratio I want to use is tangent. The tangent of theta equals 25 over 100 equals 0.25. And so now I can look and go, okay, well, what angle has a tangent of 0.25? And again, I'm glancing in my book, and it is really close to 14 degrees. Okay. In years to come, we won't be using the book, just to kind of give you a little heads up here. Instead, what we're going to do is we're going to do this on the calculator. So I'll give you a sneak peek of that right now. So what we're going to do is we're going to hit the inverse tangent of 0.25. So that little -1 says inverse tangent of 0.25. And when I type it in, I get 14.03. So really close to that 14 degrees. Another pretty straight out of the box application of this is I measure one of these sides, because it's nice and easy to measure, like that distance from my house to the wall in the garden again. But this time, let's get 150. I don't know how high my house is. It's hard to measure that. But I look here at this theta, and I find that it is 10 degrees. So again, I'm looking at what I know and what I'm trying to find. And the trigonometric ratio that I'm going to use is, again, tangent. So the tangent of 10 equals x over 150, or 150 times the tangent of 10 equals x. Either looking in my book for the tangent of 10, which is about 0.18, 150 times 0.18, or plugging into the handy dandy calculator, get the tangent of 10, tangent of 10 right there, enter, is that 0.18, 176-ish, and multiply that by 150, and I'm going to find that my house is approximately 26 feet tall. Okay. So there we have it. There is trigonometry in a nutshell. Obviously, it is a rabbit hole you can go way deep down, but there's a start. All right, next up is chapter 10, circles. Wrong button.